This is disconcerting. After you come in after breakout rooms, you're in different places on my screen. It's kind of funny. Okay, so I wrote out the proof before I popped into either breakout room. So if you have places that you're not sure of, you can go back and watch the recording. It'll be at the very end of part 1, and you can see the whole proof on the whiteboard. But it sounded like talking to both of your groups that everything was okay. Questions on this before we go into a different type of subset proof? Anything here? Okay, then the other type of subset proof that we can deal with is if we don't have set theory notation for our sets. So the easiest way to demonstrate this is for an example. For example, if we want to prove that A intersect B is a subset of A. So this is dealing with set theory properties, right? We've got intersect, we've got union, we've got all that fun stuff. We talked about these way at the beginning of the semester, I think. I'm gonna have to go back and look at my notes now. I'm pretty sure we talked about these way at the beginning of the semester when we talked about chapter 1, introduction to sets. So we talked sets. So we talked about union, intersection, difference, complement, power sets, all that fun stuff. In order to do some of your homework on this section, you might need to go back to chapter 1 just to remind yourself how all of these different set theory symbols work. So this is intersection, right? Proof is the same basic idea in terms of we want to let little a live in A intersect B, and then I need to show that little a lives in capital A. So you start with an element in whatever your kind of sort of left-hand side is, wherever you're trying to show subset, and then you need to show that element lives in the right-hand side. And I know I just wrote this down, but I'm going to change what I just did because if I have an element little a, it's a little bit tempting to think, oh yeah, that automatically exists in capital A and I'm done. So I'm going to change element to a little x here. Again, you can use whatever letter you want. It doesn't make a difference. I'm just going to go with a more generic x because then we're not assuming that x lives in capital A or anything like that. It just kind of helps us a little bit to remove the temptation to say that little a automatically lives in capital A. Okay, so for this one, we just have to do set theory logic. So because little x lives in A intersect B, we know that little x lives in A and little x lives in B. That's the definition of intersection, right? And if you have x living in A intersect B, then x lives in A and x lives in B, both. That's your definition of intersection. This is a really easy proof. We're starting off with an easy one. And so therefore, x lives in capital A and A intersect B is a subset of capital A as desired. Again, really easy one. The next one's harder, but we're starting off with a really easy one for this one. So same process, you just don't have set builder notation and you won't have equations in this one necessarily. You're going to need to use a bunch of words and some logic with set theory in order to figure out where elements live. So questions on this one before we do a harder one? That was an easy one. Let's figure to start off with an easy one. Questions on that one before we do a harder one? Okay, then how about this one? Marginally harder, not super hard yet. For example, prove that A is a subset of A union B. I'm going to prove that A is a subset of A union B. So here's my proof. We want to let X live in capital A, and then I need to show that X lives in capital A union capital B. So we're starting with an element that lives in the left side, the smaller set, what we're trying to show, and we need to show that element lives in the right side. My need to show can be written out in words. So union goes with or, right? So we need to show that X lives in A or X lives in B. That's my union. Union means or. Intersection means and. Union means or. So I'm turning union into an or. Okay, well, we know that X lives in A. So X lives in A, or X lives in B. Duh. Half of the or is true. Remember how you get an or statement to be true? You only need part of it to be true. We've got part of it to be true in this case. No problem, all good. So I'm ready for my therefore. Therefore, X lives in A union B, and capital A is a subset of capital A union B as desired. All good. These are a lot of logical sentences. It's figuring out what lives where and how to translate your symbols into words. So intersection translates into and, union translates into or. If we had one with complement, that would translate into not, etc. All right, questions on that one before we do a harder one? Promise, harder one for real this time. Any questions on that one? Okay, let's do the next one. We're gonna have 3 sets in this one. For example, let's say that we want to prove that if A is a subset of B and A is a subset of C, then A is a subset of B intersect C. I want to prove if A is a subset of B and A is a subset of C, then A is a subset of B intersect C. So this is a hypothesis, or this is a implication, right? We've got an if and we've got a then in this case. So we've got an if and we've got a then. We get to assume our hypothesis, we get to assume our if part, and then our then turns into our need to show. We haven't done an implication in a little while. So here's my proof. I get to assume that A is a subset of B and A is a subset of C. And then I need to show that A is a subset of B intersect C. It's an implication. So I get to assume my hypotheses. A is a subset of B and A is a subset of C. And then my need to show equation is the conclusion. So need to show that A is a subset of B intersect C. Okay, so we've got a need to show. We know how to do that, right? So we are going to say let X live in capital A, and then I need to show that X lives in capital B intersect C. That's my method for showing my need to show part in this particular case. So I need to show that if I have an element in the left side, that's A, then I need to show that element exists in B intersect C. And if I translate that into words, that means I need to show that X lives in B and X lives in C, right? Again, intersection goes with and, so I need to show that X lives in B and X lives in C. That's my need to show. Okay, let's use our hypothesis. So because X lives in A and A is a subset of B, we know that X has to live in B. Putting these two statements together, we know that X lives in A. That was what we assumed from up here. And we know that A is a subset of B. That was what we assumed in my hypothesis. And so therefore, since X lives in the left-hand side, X also lives in the right-hand side. Making sense? See where that's coming from? Okay. Also, because X lives in A and A is a subset of C, we know that X lives in C. Both of these are true. So this is an and. This implies that X lives in B and X lives in C. So X lives in B and X lives in C. That's great. That was my need to show in words. So now all I have to do is my therefore statement with my summary. So therefore, 2 halves, X lives in B intersect C, and A is a subset of B intersect C as desired. So sometimes set theory proofs come with an extra if statement. We have an extra if statement in this case, way back at the beginning. So there's some extra stuff that you get to assume, and then you can prove your need to show. Questions on this one? Grace, yeah.
When I was not right, this implies X lives in, or X lives in B and X lives in C. Is that necessary?
No, it's not. So the second to last line right here is not absolutely necessary. You can fill it in, you know it from the previous 2 lines. If I were doing a proof for a mathematical journal, or if I were writing up my homework, I maybe wouldn't put that in. But since this is the first time we're doing these types of proof, I want to make it completely obvious as to why we've gotten our need to show. So the statement, the line with the arrow, you wouldn't absolutely have to write. You can if you want to. Good? Answer your question? Okay. Other questions on this one? Otherwise, we got one more that we're going to do. Anybody else? Okay, one more. And normally I would make you do this one with a progressive whiteboard proof, but that is not going to work today. So we're just going to do it together here. For example, we want to prove that the power set of A union the power set of B is a subset of the power set of A union B. We're going to have to remember what power sets are. It's been quite a while since we've done those. So the power set of A union the power set of B is a subset of the power set of A union B. Let's do an aside here and remember what the power set is. So power set of, we'll do a capital C over here with a different letter, is the set of all subsets of C. Does that sound familiar way back from chapter 1? Hopefully a little bit. You can nod at me even if it doesn't, and we'll pretend that it does. All right, so what we are going to say here, and this is what we're going to end up using. Since we're talking about sets, I'm going to use a capital X instead of a lowercase x in this case. So if capital X lives in the power set of C, that is the wrong symbol. If capital X lives in the power set, not as a subset of, if capital X lives in the power set of C, then capital X is a subset of C. So that's what we're saying here. Elements of the power set are subsets. So if capital X lives in the power set of C, then X is a subset of C. That's where this is coming from. Okay, so let's go over here. We'll do our assume, our need to show. Here we go. So we want to assume, then again, we're doing capital X lives in the left-hand side. So power set of A union power set of B. And I need to show that capital X lives in the power set of A union B. Oops. So we are going to assume that X lives in the left-hand side, power set of A union power set of B, and then I need to show that capital X lives in the right-hand side. All right, so what this means is we know that X lives in the power set of A, or X lives in the power set of B, right? Union goes with or. So we know that X lives in the power set of A, or X lives in the power set of B. And I need to show that X is a subset of A union B. That's what would have to happen in order for X to live in the power set of A union B. All right, so we have an or here with my we know. We have an or here. That means we are going to need a proof by cases since we've got an or. So we've got 2 cases that we have to deal with. We need a proof by cases. So case number 1 is that X lives in the power set of A. So X is a subset of A. All right. So X lives in the power set of A, which means that X is a subset of A. And then from our previous proof, we know that X is also a subset of A union B. That was the very first one that we did. We said that A was a subset of A union B. So if X is a subset of A, then X is also a subset of A union B. This goes back to our very first proof that we did. That was my need to show. So I'm good with my proof in case number 1. I won't write a therefore or anything like that because we're still in the middle of the cases, but this lets me finish up case number 1. That's great. And then I need case number 2. So case number 2 is that X lives in the power set of B. So X is a subset of B. And I can say from the previous proof again, we didn't do it using B, but here's what I can say from our previous proof. We know that X is a subset of B union A. I can totally just switch all the letters around in the previous proof. I can be working with B's instead of A's. So we've just got the backwards direction going, but this I know is equal to A union B. If you go back to chapter 1, we had all these proof properties of sets. We had intersection and union were commutative. You could switch the order around. So we can do the order reversed in this case. That was also my need to show. So case number 2, my need to show is done, and I'm ready for therefore to bring back all my cases. So therefore, 2 halves again. X is a subset of A union B. So X lives in the power set of A union B as desired. So X is a subset of A union B, and X lives in the power set of A union B as desired. Be really careful with subset versus lives in when we're dealing with power sets. We hit this really hard in chapter 1. Remember, we had those weird brackets around, more brackets sometimes around sets or around elements and all that stuff, and you had to decide that, and it feels like that's been forever since we've done that. It comes back a little bit here. It's coming back a little bit here. So be careful with subset versus lives in. All right, there's my as desired. I've got my smiley face. That means that my proof is done. Questions on this one? Anything that you're not sure of? Why cases came up? Subset versus lives in? Anything here? Questions on this one? Lauren, yeah.
Okay, the only thing I'm a little bit confused on is like the therefore statements.
Okay.
Like, so is it always like the second part, like that it's a subset of and then it's a element that lives in, or
Oh, I did my therefore statement wrong. Sorry. That's why you're confused for this one. So X is a subset of A union B. So I totally reversed my therefore statement. Let's try it again. So I know that it's not going to fit there. P of A union P of B is a subset of P of A union B. Sorry, is that less confusing? That's what I was supposed to say? My bad. This is also why I'm lecturing live and not recording my classes ahead of time, because I wouldn't catch the things that I did wrong when I record my classes ahead of time, and then you would be even more confused. Sorry. So yes, P of power set of A union power set of B is a subset of the power set of A union B. Better, Lauren? Good, thanks. Sorry. Other questions? Other ones on this proof or stuff in general from what we're doing today? Okay, so once again, I think this is clear because it came through in the reading assignments, but give me a thumbs up that you understand why we talked about 8.1 elements living in a set. Before we talked about 8.2, which is subsets. Yes, you understand how 8.1 builds on 8.2? We've got it? Okay. All right. 8.3 next time, which is not until next week, Wednesday. So we've got Friday off and we've got Monday off. 8.3 next time is going to be showing 2 sets are equal. So that totally builds on 8.2. So we're building one more step up to show that 2 sets are equal. That's our last thing in chapter 8. So no class Friday for Good Friday, no class Monday, work on your proof notebook. The rubric is posted online. It doesn't have a grading scale yet, but you can see all the categories for the rubric and everything. And then your homework is due from chapter 8 a week and a half, Monday, April 20th. That would be Monday, April 20th. I'm pretty sure. If that's wrong, the date on Moodle is correct to go with that instead. But I think it's Monday, April 20th, I think. Grace is saying yes. Good. Okay. All right. Any other last minute questions before I let you go for Easter break? I will send out a reading assignment and homework, but any other last minute questions before I let you guys go? Going once, going twice. All right, awesome. Thank you. Have a good Easter break, or I'll see you in differential equations later. But have a good Easter break, and I will see you next week, Wednesday. So no class on Monday. Thanks, guys. Bye.